Hello, this is Dr. Keith Miller from Kansas State University, and I'm going to show a demonstration that illustrates some important concepts that underlie the understanding of weather and weather processes. And these concepts are absolute humidity, relative humidity, and dew point. Before I get started, I need to explain something called saturation. Now, you can think of water in the atmosphere as being dissolved in the atmosphere, much like you dissolve, say, salt in a cup of water. So you can keep adding more and more water to the atmosphere at a given temperature. But eventually, you'll reach a point at which the air cannot absorb or dissolve any more water vapor, at which point we say that the air is saturated. Very much like you keep adding salt to a cup of warm water, and eventually you'll put salt in and it'll precipitate out again. It won't stay in solution. We say that that water is saturated with salt. So this concept of saturation is important. So let's imagine this cup as representing the saturation amount of water in the air at a given temperature. In other words, when this cup is full, it would be saturated, represent the air saturated with water. So holding as much water vapor as it can at that particular temperature. Now, one of the important things about saturation is it's dependent on temperature. In other words, the higher the temperature is, the more water you can put in the air. Just like the higher the temperature of the water in your cup, the more salt you can dissolve in it. So the saturation amount is something that is dependent on the temperature of the air. So we need to keep that in mind. Okay, so what is relative and absolute humidity? Well, if I take and pour some water into this cup, say about that much, the amount of water that's actually in the cup is the absolute humidity. In other words, absolute humidity is just how much water is in the air at a given temperature. So absolute humidity is simply the amount of water that's in the air, the amount of water vapor that's in the air. Now, what I'm going to do is I'm going to mark on this cup where the water level is in this cup. Okay? So, remember, the full cup represents the saturation amount. Relative humidity is the amount of water that's in the air relative to the saturation amount. So if we look at this cup with this line and say, well, maybe that's 30 or 40% of the size of the cup. So we'd say that's, say, 30% relative humidity. In other words, it's relative to the saturation amount. Okay? So, again, the absolute humidity is how much water is actually in the cup. Relative humidity is relative to the saturation amount, which is the size of the cup. Now, remember I said that saturation is dependent on temperature. Well, so the size of the cup represents the saturation amount. And the saturation amount decreases as the temperature decreases. So let's say that this was warm air, and now I'm going to cool it off. I'm going to make the temperature lower. That means that the saturation amount is going to decline. The amount of water that the air can hold is going to decline. So that's as though I would make the cup smaller. So I'm going to take the scissors, and I'm going to cut the top of the cup off. In other words, I'm making the cup smaller. So now the cup is smaller. What's happened to the relative humidity? The relative humidity is gone up because now it's maybe 50% relative humidity. In other words, the cup is about half full. I haven't taken water out, I haven't put water in. The amount of water is the same. The absolute humidity is unchanged. But the relative humidity has gone up because the cup has gotten smaller. In other words, the saturation amount has gone down. So let's continue to lower the atmospheric temperature. So I will again reduce the size of the cup. So now the cup is still smaller, and now we have maybe 60% relative humidity. Okay? Again, absolute humidity hasn't changed, relative humidity is increased as the temperature falls and the saturation amount decreases. Well, I can keep doing this. So we'll lower the temperature still more. And now I've lowered the temperature. Again, I'm just reducing the saturation amount. So now the cup is nearly full. In other words, we say maybe 90% relative humidity. It's getting very close to being saturated. Now, if I lower the temperature just a little bit more, so that now the temperature has dropped so that the saturation amount is actually less than the absolute humidity. And what happens, as you see as I'm cutting the cup, is as I was cutting the cup, water was spilling out. So I've exceeded 100% relative humidity, and we call that the dew point. The dew point is the point at which saturation relative humidity reaches 100%, and at that point the air can no longer hold the water that it already has, and the water begins to condense out, and condensation starts. Now I've actually lost some water. Because I've lost water now, the absolute humidity is beginning to decline. So as I continue to lower the temperature now, the relative humidity remains at 100%. But now what's happening is that I'm lowering the absolute humidity. Because the amount in the cup, the actual amount of water, is decreasing. So after you hit the dew point, after the temperature falls to the dew point, now you begin to lower absolute humidity, and relative humidity remains at 100%. Thank you.